In this video, we shall discuss reliability design. The problem is to design a system that is composed of several devices connected in series. So you can see it in the diagram that the system has 1 to n devices all connected in series, where Ri is the probability that device I will function properly. Then the reliability of the entire system is obtained by the product of Ri's ranging where I ranges from 1 to n. If suppose we have a system with 10 devices and the reliability R is given as 0.99, then the reliability of the whole system now becomes 0.99 raised to 10, which tends to be something like 0.904, which is nothing but the system works perfectly for 90% of the time, whereas 10% of the time the system may not work properly. In such case, in order to make the system more reliable, we need to duplicate the devices at each stage. So we do parallel connections of the devices. That is, in stage 1, we can have multiple instances of device D1. Similarly, at stage 2, you can have multiple instances of device D2. That is, if one instance of D1 fails, then the other one can start working. For example, if R1 is the reliability of device D1 working properly, if R1 is the reliability of device D1 working properly, then the probability of one device of stage 1 to fail will be 1 minus R1. Or I can generalize it to be the probability of one device of stage I will fail can be given as 1 minus Ri. Please make a note of all these definitions. And the probability that stage I will work properly is given by pi I of mi, which is equal to 1 minus Ri raised to mi. So 1 minus Ri whole raised to mi is nothing but the probability of all devices in stage I that will not work properly. So this part 1 minus Ri raised to mi gives us the probability of all devices in stage I that will not work properly, right? And the probability that the stage I entirely will work properly is given as pi I of mi, which is equal to 1 minus of 1 minus Ri whole raised to mi. In reliability design, we try to use device duplication to maximize reliability with given cost. Therefore, the objective here is that we are given a cost and we should obtain maximum reliability of entire system with n stages. The reliability of entire system. Reliability of entire system is given as product of pi I of mi, where mi stands for number of copies of device I in stage I, and Ri stands for reliability of one device of stage I, subjected to the condition that summation I is equal to 1 to n Ci Mi is always less than or equal to C. That is, summation of Ci Mi, where I is between 1 to n, is always less than the given cost. And the number of copies of devices Mi should always be greater than or equal to 1 for all the devices, where Ci stands for cost of one device I of stage I, and C stands for the total cost of the system. The maximum number of copies of any device that we can keep in a stage I is given as Ui, which is equal to the floor of C plus Ci minus summation of j is equal to 1 to n Cj whole divided by Ci. The denominator here is Ci. So summation of summation of Cj, where j ranges from 1 to n, is what we should take is equal to C1 plus C2 and so on till Cn. That is, we should take at least one copy of each device, which is equal to the summation of Cj's. The remaining cost after taking one copy of the device can be given as C minus summation of j ranging from 1 to n Cj. For example, Ui is equal to floor of C minus summation of Cj plus Ci divided by Ci, where Mi stands for number of copies of device I should be in the range 1 to Ui. So it means that Ui stands for upper bound, stating the maximum number of copies of type device Di that can exist in a stage I. That is, we should always remember that Mi cannot be greater than Ui. So the number of Ui stands for the upper bound of number of devices that can exist in the stage I. Here, let us see an example. We are to design a three-stage system with device types A, B and C, and the costs are $30, $15 and $20 respectively. The cost of the system is to be no more than $105. The reliability of each device type is given as 0.9, 0.8 and 0.5 respectively. So the very first step is, let us calculate the maximum number of copies of each device type that we can take. So how many devices of type A can exist in the system can be given by the formula U1, which is equal to, so the formula is C plus C1 minus summation of summation of Cj such that it ranges from 1 to n whole divided by Ci. So i's initial value here is 1. So this formula now becomes C plus C1 minus summation of Cj So Cj's are cost of all the devices, the whole thing divided by the cost of C1, right? So will now become this will now become U1 is equal to the floor of C. The cost of the entire system is 105 plus C1. So C1, the cost of the first device from the problem is 30 minus the cost of all three types of devices. So C1 is 30 plus the next one is 15 plus the cost of C type of device is 20. So 30 minus 65 whole divided by the cost of the first type of device, that is 30. So U1 now reduces to 70 divided by 30 is floor, which is equal to 2. So it means that Mi, that is number of copies of device type A that can exist in the system, is 2 or less than 2. So similarly, we also have to calculate the number of devices of type B as well as the number of devices of type C that can exist in the system. So by applying the same formula, that is Ui is equal to C plus Ci minus summation of Cj, where j ranges from 1 to n whole divided by Ci, shall give us the value for both u2 as well as u3. I have already calculated the values of u2 and u3. So the value of u2 will be equal to 3 and the value of u3 will be equal to 3, stating that at second stage you can have 3 or less than 3 number of copies of the device of type B. So similarly, at stage 3 you can have 3 or less than 3 instances of device of type C. So the budget in which we are supposed to construct the entire system is given to be $105, and we already know that the probability that stage I will work properly is given as pi I of mi, which is equal to 1 minus of 1 minus of 1 minus ri whole raised to mi. So given in the problem is the reliability of the device A with having only one instance of device type A is 0.9 and the cost of the device is $30, and the reliability of device B for one instance of device of type B is 0.8 and its cost is 15, and from the problem itself the reliability of device C is 0.5 and the cost of each device here is 20, right? And S raised to I gives us a set of all tuples of the form f comma x which are generated for various sequences of m1 m2 mi, that is number of copies of devices in each stage. So where F stands for reliability and X shall stand for the cost. And similarly, the set S raised to I j is the set S raised to ij gives us the details of stage number, that is I stands for the stage number and j stands for the number of devices used at that stage. So for example, S of 11 means that number of devices are 1, that is means one device of type A at stage 1. So similarly, S raised to 1 2 means that two devices of type A at stage 1. So very first time we shall consider device 1 and calculate the reliability and cost if we consider one copy of the type device 1, that is device A. So when M1 is equal to 1, when M1 is equal to 1, S of 1 1, that is S of 1 with number of devices, that is one device in stage 1 is given as having reliability 0.9 and its cost to be 30 from the question. And similarly, for next time when the number of instances at stage 1 is equal to 2, then we get S of 1 2, which is nothing but obtained by the equation 1 minus of 1 minus R1 whole raised to 2. We are making use of mi is equal to 2 because we are trying to take into consideration two copies of device A in stage 1. So 1 minus of 1 minus R1, R1 is nothing but 0.9 whole raised to 2 is tending to something like 0.99 with the cost to be equal to 60 because the cost of one device is 30. So cost of two device here becomes equal to 60. Then we combine both S1s. So that is S of 1 1 and S of 1 2 to get a tuple S1 which has the values for M1 equal to 1, that is one instance of device type A as well as two instance of device type 2. So here you can see the reliability of having one device is 0.9 and the cost of it is 30. Similarly, the reliability of having two devices of type A is 0.99 and the cost is 60. Now, in the second step, we consider device B. That is, we first calculate S2 of 1. That is, how many one instance of the type device 2, that is device 2 is nothing but device of the type B. So, how do we calculate it? So, in order to calculate this, we consider the set S raised to 1. So when M2 is equal to 1, we obtain its reliability by multiplying the previous reliability 0.9 with the reliability of having one device of the type B that is given in the question as 0.8, which gives us a value 0.72, comma, we are taking only one instance of the type device B. So this previous cost 30 plus the current cost of one device of the type B, that is 15, gives us a value 45. So similarly, the next tuple is for if you have two instances of device, if you have two instances of device B, then the formula now becomes equal to 0.99 into the reliability of device B, that is 0.8, giving you a value 0.792, comma, the cost is 60 plus the cost of one device here is 15, giving you a value 75. So then combining both, so it is giving us the reliability of having one copy of device type B in second stage. So similarly, you now calculate the reliability of having two device instances in second stage, that is in the second stage, that is two device instances of device type B in the second instance. With reliability of stage 2 with two copies of device B given as 1 minus of 1 minus R2 whole raised to 2, which tends to be 1 minus of 0.8, the reliability of device B whole raised to 2, which tends to a value 0.96, which tends to a value 0.96. So S22 is equal to, from the previous step, we now have here 0.9 into 0.96, giving us a value 0.864, 60. The other tuple gives us a value 0.99 into 0.96, which is nothing but 0.9504, comma, the cost here is 60 plus 30, that is there are two instances of device B, so 15 plus 15 is 30, 30 plus 60 is 90, which says that with the cost of $90 you are getting the reliability of 0.9504, or I can say 95%. The cost of the entire system here is $105. So we will be left out with 105 minus 90, that is just $15. But the cost of the third device is $20. So it means that we cannot buy the third device if we go with this. That is, if we go with purchasing, or we go with spending $90 for a reliability of 95%. So therefore we discard it, as this configuration will not leave us with adequate funds to complete the system. So the next time we calculate S23, that is the reliability of stage 2 with 3 copies of device type B, which is given by 1 minus R2 whole raised to 3. So it is nothing but 1 minus R2 is 0.8 whole raised to 3, which we get it to be 0.992. So S3 from the previous state we get it as 0.9 into 0.992, 30 plus the cost of each device of the type type B here is 15. So we are trying to consider all three devices. So 15 into 3, that is 40. So 30, this 30 plus 40 gives us 75. So similarly, the next option that we calculate is 0.99 into 0.99 into 0.992, which tends to be 0.982, comma, the cost is 60 plus 45, that is 105. So again, we are given with the total cost of developing the system to be $105. So when you spend $105 on the third instance of device B, then you cannot construct the system further. So therefore you discard this tuple. So therefore S23 you get a tuple with maximum reliability to be 89% with the cost to be $79.75. So combining S2, you get tuples 0.72, 45, 0.792, 75, 0.864, 60, and 0.8928, 75. So you have two instances where the cost is $75 and reliability tending to be 0.8928, and in the other case the reliability is 0.792. So the cost is same, but here the reliability is less, so therefore we discard it and we consider the tuple 0.8928. So now we calculate S31, that is at stage 3 you are going to have only one instance of device type C. So this is calculated by making use of S2. So S3 of 1 is nothing but 0.72 into 0.5. So the reliability of C is 0.5. So 0.72 into 0.5, comma, the cost would be 45 plus the cost of one device here is 20. So you get 0.36, 65. So similarly, the next possible value is you have 0.864 multiplied by the reliability of device C, which reduces to 0.432, comma, the cost is 60 plus 20, that is 80. And similarly, the third possible value would be 0.8928 into 0.5 into 0.85, which is 0.4464 with a cost of 75 plus 20, that is 95, right? So then this was for M3 is equal to 1, that is you have only one device instance of the type device C. So then you calculate M3 is equal to 2, that is you calculate S3 2. So the reliability of stage 3 with two copies of device of the type C is given as 1 minus of R3 whole raised to 2, which is nothing but 1 minus of the reliability of device C is 0.5 whole raised to 2, which reduces to 0.75. So now S32 is given as 0.72 into the reliability of stage 3 with 2 copies of device C is 0.75. So it reduces to 0.54, comma, the cost here should be 45 plus the cost of having 2 devices of the type C is 20 plus 20 is 40, 40 plus 45 is 85. So the first tuple. Second tuple, 0.864 into the reliability, that is 0.75, which reduces to 0.648, comma, the cost would be 60 plus 2 instances of the device with cost 20, that is equal to 100, right? And the third value need not to be calculated because the cost itself becomes 75 plus 2 instances of the device. So the cost would be 40, 75 plus 40 now becomes equal to 115, which goes beyond our budget, that is 105. So therefore we discard the third instance. So in S32 we have only 2 tuples with reliability 0.54 at a cost of 85, and the second one reliability of 0.64 at the cost of $100. So similarly you calculate the value for M3 is equal to 3, that is the reliability of stage 3 with 3 copies of devices. So it is reliability of stage 3 with 3 copies of devices is given as 1 minus of R3 whole raised to 3. So which is equal to 1 minus of 1 minus 0.5 whole raised to 3, which is nothing but 0.753. So again, by making use of tuple S2, you calculate the tuples lying into the group S3 of 3 and then combine all the values to form S3. I have already calculated S3 for you. So S3 has 3 tuples in it, 0.36, 65. It has 0.432, 80. It has 0.54, 85, and the last tuple, that is 0.648 at the cost of $100. So it means that you can observe from all these tuples that this is the maximum reliability, that is maximum reliability is 64%, 64.8% at the cost of $100. So we got 0.648, 100 when we selected 2 copies of device 3 and when the reliability was 0.75. So we backtrack to all tuples from which we had obtained a value of a reliability of 0.648. Therefore, we end up taking 2 copies of device C and 2 copies of device 2 and 1 copy of device 1.